It'll be helpful to take a look at the material to understand what's going on with how we are determining the colors for our spheres. When you look at a color in a material, typically you're going to be thinking about it in terms of RGB, which is red, green, and blue, but there's another way to think about it, which is going to be HSV, which stands for hue, saturation, and value. So if you look at this little circle here, that's going to be the output color, and if I move this stuff around, you can see that it's going to kind of move around our color sphere somewhat randomly. So if we wanted to actually do a fully saturated ring here, we would need to be modifying these channels independently. Alternatively, we can use hue. And if you look at that little circle as I drag hue up and down by itself, we're getting the desired output here, which is basically cycling through the full spectrum of those colors. So what we're doing over here with the material, if I set this to red, I want it to be mathematically red, so 100, I'm going to convert it from RGB to HSV, which means the red channel or the X channel respectively is going to be driving our hue. And we're going to do the same thing down here with the second color, which is almost red, but just a little tiny bit different. Let's see if I can open that up, right? So it's like, this is red, and this is the color that I have selected. So what this is going to do is it's going to say like, okay, well, whatever red is in terms of its hue, we have this other color here, and we want to travel between those two. And we're going to use this lerp node to do that. Lerp is a linear interpolate, which is going to blend between two inputs, A and B, as determined by an alpha value. So this is presumed to be a float that is between 0 and 1. So 0 is going to output this value, and 1 is going to output this value. And we're going to use a parameter that's exposed to a material instance to drive that alpha value. And once we've done that, we're going to convert it back from HSV to RGB and pipe it into our base color of our material here. So to create the hue, you're just going to right click over here and type in constant, and it's just going to be a regular old constant. We're going to right click on it and then convert it to parameter and name it something that makes sense. And then to create these are constant 3s, you just type in constant 3 vector there, and that'll give you the color. Same deal with this, just right click and type in RGB, and over here you just want to right click and type in lerp. Otherwise, this material is a standard material. Once you've got the material in the content browser, you can right click on it and select create material instance, and that will give you this material instance down here. And the material instance has a lot of things that are nice about it. One of them is the hue is now exposed as a parameter, and we can modify it very easily without requiring any recompilation of shaders, and the value will update quickly. Okay, so that's the material. So we're just going to change this value, this parameter here, and we're going to get a different color. On the blueprint side, we're going to need an easy way to access all of the spheres so that we can assign a dynamic material instance to each one of them. So I'm going to create a new variable, call it spheres, and we will set the data type to static mesh component. And the reason it's got to be a static mesh component is because the return value of this node is a static mesh component. I'm going to go ahead and get a reference to our spheres variable. And we can add each sphere to it as it is created. Go ahead and copy these, Control-C, Control-V. And we'll grab the second sphere as well. So now we've got our spheres stored here in an array. I'm going to create a new custom event. And name it apply color. We'll grab our spheres and iterate over them with a for each loop. So if we went through and assigned this material instance to each sphere, they would all be the same color because there's only one of these. So what we need to do is create an instance of this instance for each sphere. And that might sound a little bit weird, but we should have talking about. So what we're going to create is a dynamic material instance. And you can see there are two options here. I'll show you what they both look like. One of them is going to be expecting as its target a primitive component and one of them has no expectation in terms of the target. So we're going to go ahead and delete that one. And this is just going to create a dynamic material instance that's going to be floating around in the ether. This is a reference to each sphere. So we want to go ahead and set the material for this sphere to our material instance. So we create a dynamic material instance of this material instance right here, and then we assign it to our sphere, right? Okay, hopefully that's clear. And then once we've got the dynamic material instance, we want to go ahead and set a scalar parameter. So scalar essentially just means a float. It's a decimal point number. Set scalar parameter value. So if this is not a dynamic material, we cannot set a scalar parameter. There's no expectation that it's going to change. But if it's dynamic, we can set it all we want. Okay, so now we need to tell it what is the parameter name. It's called hue. And we can confirm the spelling on that. Just take a look at there. Whatever that is what it needs to be. And then we've got to tell it, as we create this dynamic material instance, what is this parent going to be? Parent's going to be this. I'm going to go ahead and basically browse to it in the content browser, which is going to select it. And then once it's selected, I can go ahead and pop it in there. Next, I need to tell it what the value is going to be. So easy way to think about this is the array index. The first time through it'll be 0. The second time through it'll be 1, 2, 3, 4, and so on. So what we can do is we can basically take the array index and divide it by the length of the number of spheres. So walk you through it real quick. First thing we need to do is cast this to a float so we don't lose our decimal point, because that's the actual information that we're going to be putting in here. So if this was let's say we have 10 spheres and we are on the first one, the value that we want to generate is going to be 0.1. So 1 divided by 10 is 0.1. If we were on the fifth sphere, we'd want to generate a value of 0.5, and 5 divided by 10 is 0.5. So that's how this is going to work. Go ahead and grab the length there. So we'll take this value and divide it. Plug it in there, and then that will be our new value. Compile and save. So now we need to call this function, and we don't want to call it after rotate spheres because rotate spheres has a looping timeline in it, so it's going to continue going. We want to slot it in right here. Grab our apply color function or event. We'll hit compile and save and take a look. Cool. All right, so that is a simple example of how you can generate geometry, position it, set it up so that it's got some controllable, predictable pivots, apply some motion using a timeline, and then generate, apply, and modify some dynamic material instances there. So I use this general workflow all the time in my personal projects. So I hope you find that very useful. And in the next video, we will break down the process for creating the original cinematic with the spinning sphere that I showed at the very beginning of the series.